Hello dear students, welcome to Konar classes. In this session we are going to solve few questions on differential equations. So let's look into the questions one by one, and most importantly you also start solving along with me. Okay, the first question, here it is. Verify that the function y equal to c1 e power ax cos bx plus c2 e power ax sin bx, where c1 c2 are arbitrary constants, is a solution of the differential equation d2y dx2 minus 2a dy dx plus a square plus b square into y equal to 0. Okay, so how to proceed, dear students? The first of all, let us write the function what has been given. This is y equal to, you see dear students, that e power x we can take common, so we take e power ax common, and then we write c1 cos bx plus c2 sin bx. Now dear students, let's differentiate both sides with respect to x. Then what we are going to get? Dy dx. Now these two are functions. The first function is e power x and second function is c1 cos bx plus c2 sin bx. So product rule of differentiation. The first is that e power ax into ddx of this entire function c1 cos bx plus c2 sin bx. What it will be? It will be c1 into differentiation of cos bx is minus sin bx. So I write minus sin bx into differentiation of bx is b plus c2 into differentiation of sin bx is what? Cos bx. So cos bx into differentiation of bx is b. Okay, plus we write the entire thing c1 cos bx plus c2 sin bx. c1 cos bx plus c2 sin bx into differentiation of e power x is e power ax into differentiation of ax, that is a. Correct? Done. Now one thing we are going to do, dear students, you see that we need to find another order of differentiation d2y dx2 as it is given in the question. So for that, let us see whether we can simplify this or not. What we see, c1 cos bx plus c2 sin bx into e power x is equal to y. So this is the stuff, that is nothing but y, right? So instead of writing this entire expression, I can directly write it is y. So what we can write, dear students? So instead of this thing, we can write ay. Okay. So we write here ay. Okay. Now we can take b common from these two. So what we can write here? So from there, if we take b common, so we get, this implies dy dx is equal to b into e power ax into c2 cos bx minus c1 sin bx. c2 cos bx minus c1 sin bx plus ay. Now dear students, let's differentiate both sides with respect to x. Okay, what we are going to get? So this implies d2y dx2, that is equal to, we can take b common outside, b outside of the differentiation because it is a constant. Then what we are going to get? E power ax into differentiation of this. So what we are going to get? c2 differentiation of cos bx is minus sin bx. So minus sin bx into differentiation of bx is b minus c1 differentiation of sin bx is cos bx is into cos bx into differentiation of bx is b. Correct? This is done. Plus what we can write? that C2 cos bx minus C1 sin bx, C2 cos bx minus C1 sin bx into ddx of e power ax, that is e power ax into a, that is e power ax into a, correct? That is the completion of the entire differentiation of this stuff. Okay, and after that differentiation of ay, that is a dy dx, so that we can write is that a dy dx. Okay, now let's simplify. So before we simplify, dear students, so one important part is that what we see that C2 cos bx minus C1 sin bx into e power ax we can simplify here. Okay, so let's look into this particular one. So from here what we can get, whatever I am writing in the green color, from here what we write, e power ax into C2 cos bx minus C1 sin bx, e power ax into C2 cos bx minus C1 sin bx, that is equal to dy dx minus ay by b, that is equal to dy dx minus ay divided by b. Okay, so what we can write, dear students, so then instead of this particular thing, that e power ax into C2 cos bx minus C1 sin bx, we directly can write this thing dy dx minus ay by b. So let's write this thing. So let's remove this thing. We write dy dx minus ay by b, dy dx minus ay divided by b into this a as it is, so we can remove this a. Okay, and then a dy dx, that is which is added, that will write after that. So plus a dy dx, correct? So now let's simplify further. So what we are going to get, dear students, from here is that, so this b and this b we can take it out and it will be b square with this expression. So let me write it here. So this implies d2y dx2 is equal to, so this particular thing we are multiplying with b, then what we are going to get, it will be b square. So from here one b and here one b, that we multiply with b, that become b square, into this minus and this minus, we will take it out, so minus will come out, e power ax into c2 sin bx plus c1 cos bx, or you can write c1 cos bx plus c2 sin bx, correct? Done. Plus this b into entire expression, so b got cancelled, we write a into dy dx minus ay plus a into dy dx minus ay plus this a dy dx, correct? I hope you understood. Please do along with me, that is very important. If you just look into it and not doing, you will not able to understand. Okay, you will not get the exact feeling. In the exam hall you will face difficulty. Okay, so please do. You need to do all this derivation in your own hand. Okay, so let's do in this part. So from here we come to this part. So this implies what, dear students? d2y dx2 is equal to d2y dx2 is equal to minus b square minus b square into e power ax into c1 cos bx plus c2 sin bx is nothing but y, correct? So what we can write here is that, so minus b square into y. I repeat once more, dear students, I am talking about this entire expression. If you look into this entire expression is nothing but y, correct? E power ax we took common, c1 cos bx plus c2 sin bx, that's why you write minus b square y plus this one, this is d, plus a dy dx minus a square into y, correct, plus a dy dx plus a dy dx. So from here what we get, dear students? So from here we get d2y dx2, okay, this minus b square y minus a square y become minus of a square plus b square into y, so that we take into the left hand side become plus a square plus b square into y, and this a dy dx become 2a dy dx, so I take it in the left hand side minus 2a into dy dx is equal to 0. We got it. So finally what we can write, dear students? So this implies d2y dx2 minus 2a dy dx minus 2a dy dx plus a square plus b square into y is equal to 0. This is what we actually want to prove, correct? Before we proceed to the next question, I would like to tell you a couple of points. One is that, think about this particular function has been given. This is a, kind of a general solution as it is having arbitrary constants c1 and c2. Now if the question is changed little bit, that if the general solution of a differential equation is this and you need to form the differential equation, one thing you are pretty sure. What is that? The corresponding differential equation is going to have order 2. Why? Because in the general solution there are two arbitrary constants, and we know the number of arbitrary constants in a general solution of a differential equation tells the order of the differential equation. It is equal to the order of the differential equation. I repeat once more. The number of arbitrary constants in a solution of a differential equation is equal to the order of the corresponding differential equation. So then also we can derive something like this. Okay. Now let's proceed to the next question. Okay, so let me write down the question, dear students. So here it is. Let me take it from my notebook. Question is, form the differential equation. Form the differential equation of the family of circles of the family of circles in the second quadrant, in the second quadrant, in the second quadrant and touching the coordinate axis, and touching the coordinate axis. Okay. So let us first give a visual representation of this question. Okay. What is this? That form the differential equation of the family of circles in the second quadrant and touching the coordinate axis. That means what, dear students? If the circle is something like this, okay, so we can draw the coordinate axis something like this. Suppose this is positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, this is negative direction of y-axis. Okay. Now, this particular question represents this one, family of circles. So there will be many circles, something like this. One I have drawn many circles where it is in the second quadrant, it is touching both the coordinate axis. We need to find a differential equation representing this family of circles. Okay. So let us take this one. So if we take this particular one, dear students, so what we get here is that, let's take this particular point as the center. Now suppose this point is A, where it touches the x-axis, and this is the point B where it touches the y-axis. Let's assume this particular circle's radius is A. So then what we can say, this distance is A, this distance is also A, correct? So what is the coordinate of the point A? That will become minus A comma 0. Coordinate of the point B will become 0 comma A. And the coordinate of the center, if this point is center, its coordinate will be minus A comma A, correct? So what will be the corresponding equation of the circle? It will be x minus A complete whole square plus y minus A complete whole square, that is equal to A square. So this is the equation of a circle having center at the point minus A comma A and having radius A unit, correct? So this implies what? This implies x plus A whole square plus y minus A whole square is equal to A square, correct? Now let's simplify a little bit. So this implies x square plus 2 into A into x plus A square plus y square minus 2 into A into y plus A square is equal to A square, correct? Then what we get? This A square and A square got cancelled. And what we will end up with, dear students? So this implies x square plus y square plus 2ax minus 2ay plus A square is equal to 0, correct? Now what we are going to do, dear students, is that we need to form a differential equation which represents this circle. Now we can vary A and we get different circles. That's why it becomes a family of circles. So that means what? A becomes an arbitrary constant. Now, as if this is a curve having one arbitrary constant A, and we need to form a differential equation, for which this is the general solution. So what we need to do? We need to eliminate this arbitrary constant A. That means what? We need to remove A or eliminate A, the way you want to say. And how many arbitrary constant is there? Only one arbitrary constant, that is A. That means the corresponding differential equation is going to have order 1, correct? So now let's proceed towards that. So we need to differentiate both sides of this equation with respect to x. And what we are going to get, dear students? So this implies 2x plus 2y into dy dx. So let's write dy dx as y dash plus 2 into A minus 2 into A into y dash, and differentiation of A square is equal to 0. Right hand side is 0. So from all these things we can take A comma 2, actually we can cancel out. So what we are going to get, dear students? So from here we get x plus y into y dash plus a into, we already, let's remove this a first, remove the 2 first, let's first cancel the 2, plus a minus a into y dash, that is equal to 0. Okay, now what we are going to do, dear students, let's first find the value of a. So if we find the value of a from here, we get a is equal to, x plus y into y dash divided by y dash minus 1. Correct? This is the value of a. Now, dear students, all we need to do is that, apply this value of a in this equation. Okay. This value of a we are going to apply in this equation and we will get the required differential equation. So how to proceed, dear students? So for that, what we are going to do, so I am writing it here. So this implies x plus a. So x plus, what is the value of a? X plus y dash, x plus y into y dash divided by y dash minus 1, this complete whole square, okay, plus y minus a whole square. So let us remove this particular portion. Okay, so plus y minus a minus x plus y dash divided by y dash minus 1. Okay, complete whole square, that is equal to a square. A square is what? X plus y dash divided by y dash minus 1 complete whole square. We got the differential equation, but that is not in a very very optimized manner. We need to simplify. Okay, so for that, what we are going to do, we are going to multiply both sides of this equation by y dash minus 1 whole square. Then what we are going to get, so this implies we are going to get that x into, second bracket is not required. What we can write is that x into y dash minus x plus y into y dash, this complete whole square. Correct? X into y dash minus x plus y dash, the whole square, plus here we can write is that y into y dash minus y minus x minus y into y dash complete whole square is equal to x plus y into y dash complete whole square. Okay, correct? So now, dear students, what we get? This minus x plus is got cancelled. This y dash minus y dash get cancelled, and we get in a little better manner. Now if you see x y dash and y dash, from here we can take y dash common. So from here what we are going to get, so this implies if we take y dash whole square common, we get x plus y complete whole square. Correct? And here minus y minus x whole square, that means x plus y whole square. So that is equal to x plus y complete whole square. If we take minus common, then minus of x plus y complete whole square minus 1 whole square is plus 1, hence we get this one. In the right hand side, what we get, dear students? So x plus y into y dash complete whole square. So now from these two, in the left hand side we can take x plus y whole square common. Okay, so what we write, dear students, that x plus y whole square common, then we get Okay, and here we write y dash whole square plus 1 is equal to x plus y into y dash complete whole square. And this is the required differential equation, dear students. Okay. You see, as I said, few minutes back, as there is only one arbitrary constant, hence the given differential equation that the differential equation what we found is having order 1. Okay, now let's proceed to the next question. Okay, so let me write down the next question here. Okay, so let me write down the question from my notebook and let me write it down here. Find the particular solution of the differential equation log dy dx log dy dx is equal to 3x plus 4y, given that y equal to 0 when x is equal to 0. Okay. So if we solve this differential equation log dy dx is equal to 3x plus 4y, what we are going to get? We are going to get a general solution or primitive. Now on that general solution, if we apply x equal to 0, y equal to 0, we will get a particular solution. General solution will contain the arbitrary constant, and once we find the once we apply the value of x equal to and y x equal to 0 and y equal to 0 in the general solution, we will get the value of the arbitrary constant. We will apply that value of the arbitrary constant in the general solution, we will get the particular solution. Let's do it. Okay, but what method we are going to apply here? We have learned earlier that we can solve a differential equation by means of variable separation or homogeneous differential equation or linear differential equation. Let's see which category this differential equation is actually falling. Based on that, we can find the solution. So what is given, dear students? Log dy dx is equal to 3x plus 4y. So dear students, so from here what we can write? This implies dy dx is equal to e power 3x plus 4y. Correct? This implies dy dx is equal to e power 3x into e power 4y. You may ask, sir, why you have done this? Okay, the reason is that as we know log dy dx equal to 3x plus 4y gives us dy dx equal to e power 3x plus 4y, we can make it variable separation. So as if this is a function of x and this is a function of y, right? If you remember, if we can express a function in xy as a product of two functions in which one function is only on x and other function is only on y, we can apply the differential equation using variable separable. Correct? So from here what we can write, dear students? So this implies e to the power minus 4y dy is equal to e to the power 3x dx. Correct? After that we will integrate both the sides. E to the power minus 4y dy integration, what it will give us, dear students? So that will give us that e power minus 4y divided by minus 4 is equal to e power 3x divided by 3 plus 1 integrating constant says c1. Correct? Now from here let's proceed to the next step. Let's come to here. Okay, so from here what we are going to get? So this implies that if we multiply both sides by 12, then what we are going to get? Minus 3 into e power minus 4y is equal to 4 into e power 3x plus 12 c1. Or we can write that 4 into e power 3x plus 3 into e power minus 4y is equal to minus 12c1, and that we give as a new arbitrary constant called c. Okay, so what we can write? We can write here where c is equal to minus 12c1. Correct? Now this is a general solution having arbitrary constant c. Now we need to find the particular solution. For that we need to apply this initial condition that x equal to 0, y equal to 0. So if we write here that x equal to 0 and y equal to 0, in this general solution what we are going to get? 4 into e power 0, 4 into e power 0 plus 3 into e power minus 0 is equal to c. So from here what we get? That c is equal to 4, e power 0 is 1, and 3 into e power minus 0, that is also equal to 1, 4 plus 3. That means we get the value of c as 7. Correct? Now this value of c as 7, if we apply in this general solution, we are going to get the required particular solution. So what is the required particular solution, dear students? 4 into e power 3x plus 3 into e power minus 4y is equal to 7. And this is the required particular solution to the given differential equation. Okay. So dear students, with this note, let me conclude the session here. Please log into the online test platform at konarclasses.com and appear for DPP, that is daily practice problem, followed by PT, that is practice test, followed by UT, that is unit test, followed by MDT, that is module test, and finally MT, that is mock test. With all this, your preparation will be rock solid. Thank you very much. Bye bye.